A Waszp is a new style of foiling sailboat. Sailboats move in air and water, so they are affected by both aerodynamic and hydrodynamic forces. The aerodynamic forces will act on the sails, which will propel the boat forward because when the wind hits the sail, the airflow will be redirected and a forward force will be created. However, this also results in a side force causing the boat to slide sideways. This force must be cancelled out by a hydrodynamic force from the foils. In order for the boat to travel in a straight line, the hydrodynamic forces, also known as the center of lateral resistance, should line up with the center of effort for the aerodynamic forces. This is the same thing for a boat that's foiling. Flow attachment allows a foiling sailboat to take off by affecting both the sail and the foils. On the foils, the upper surface of the foil deflects the water downwards because the flow of the water sticks to the surface and follows the tilted foil. Then it joins back up with the water on the bottom of the foil. This pressure difference between the water on the top and bottom of the foil generates the lift that causes the boat to take off like an airplane wing. However, the boat cannot take off unless the wind is creating flow attachment on the sail, which is how any boat, foiling or not, generates speed. The angle of attack, aka pitch, also affects the stability of a foiling boat to take off. As it is increased, the point of minimum pressure moves forward in the boat and the size of the adverse pressure gradient increases. This means that the lift component of the hydrodynamic force will increase. However, at a certain point, a boat will stall when the drag component increases too much, if you create too much lift. This is why on a Waszp, the pitch of the rudder should be somewhere in the middle for maximum lift at takeoff, and you must not oversheet the main sheet. A Waszp foil has a vertical and horizontal component. The T-shaped foil, when vertical in the water, will give all the lift force upwards and therefore will allow the boat to ride high. However, if we can heel the boat over to windward while going upwind, then a part of the vector of the lift component is also pointing upwind. This means that the foil can be lifting us upwind closer to the mark. Also, when you heel the boat to windward, when going upwind, part of the vertical foil becomes part of the horizontal section of the foil, generating more lift. On top of this, it will also give us more riding moment, meaning that we can sheet the mainsail in harder and generate more power for the sail. Another factor to consider is reducing drag. This means that we ride as high as we possibly can on the foils before they ventilate in order to reduce the amount of foil in the water and therefore reduce the amount of drag. Balancing between foil ride height and windward heel is very important in order to make T-shaped foil boats go fast, especially upwind.